Okay, 6.1, we're dealing with roots and radical expressions. So we've done radical expressions before. Remember when we had to take the I out? So it isn't completely new. So first we're just going to label the parts of a radical expression. So to find the root of a number, the inverse operation of it's the inverse operation of raising the number to that power. So the square root of a is the inverse of a squared. So here we have the index, which is this number that goes outside. So before we've only seen it with no number, so it's like an implied 2. So what we've been doing is like our index has been 2, but when the index is 2, you don't write that number there. And then we have the radical sign, which we've seen before, and the radicand is the number that's under the square root, under the radical. So recall that the radical symbol is used to indicate roots. The index is the small number to the left of the radical symbol that tells you which root to take. For example, when we have the index of 3 right here, it represents a cubic root. So since 2 cubed is 2 times 2 times 2, that's equal to 8. The cubed root of 8 is equal to 2. So if we had the cubed root of 8, what are 2 factors of 8? 4 and 2. Now what are 2 factors of 4? 2 and 2. So before, what we've done in the past was we circled the pairs that we have and we take out the pairs. But now when we have an index of 3, we have to circle groups of 3. So we circle all 3 of the 2's, and what comes out on the outside?
2.
Just a 2. So the cubed root of 8 is 2. And that's our answer. It is like the other section, but this time we're doing 3 and more.
So the problem is going to be like 3.
So like the cubed root of a number. We only circle pairs of 3's, and remember, whatever doesn't get circled stays on the inside. Okay, next we have a number raised to the power of 1 over n is equal to the nth root of that number. So if we have a number raised to a fraction, that fraction is like our square root. So if we have 5 raised to the 1/4, we're taking the 4th root of 5. So if we have the 4th root of something, we're going to circle 4 numbers. Yeah. 2. So 3 raised to the 1/2 is the same thing as saying the square root of 3. So it's just a different way of writing what we've done before. Okay, simplify each expression. So now we have the cubed root of 343. What are some factors of 343? Not 3. Try again. What? There's really only one number that goes into it, so this is a tough one. Not 343. There's another number other than 1 in itself. What's another prime number we have?
7.
7. So we have the cubed root of 7 times 49. What are 2 factors of 49? 7 and 7. So what are we going to do now?
7. Just write 7.
Just write 7. So we circle our group of 3. So the 3 7s, and what's our answer? 7. Okay, let's look at example B. So now we have the 5th root of 32 plus the square root of 9. So we're just going to treat this as 2 separate problems, and then we're going to add them together at the end. So what are some factors of 32? 2 and what?
16.
16. What are our factors of 16? 8 and 2.
And then 4 and 2. And then 2 and 2.
So we have 4 and 2. And then 4 breaks down into 2 and 2. So remember, now that we have the fifth root, how many are we circling? 5. So we need to circle 5 of the same thing. So how many 2's do we have? 5. So if we circle all 5 2's, what's our answer going to be for this part? 2. So the first part, our answer is 2. But now we need the square root of 9. What does 9 break down into? 3 and 3. And that's it. How many numbers do we need to circle here? 2. Remember, if we don't have a number out here, an index number, then it's implied that it's just 2. So we do the same exact thing we've done before. So the square root of 9 is 3. And now we need to add the 2 together. So what's our final answer? 5.
It was like subtract.
Right. So we kind of just treat this as like step 1 is this 32 to the 1/5, and then step 2 would be this, and then we just add them at the end.
How big would the index get?
I think the biggest it gets is I think 5 in the homework.
Okay.
There might be one that says 6. Okay, next page. So simplify each expression. What's the first thing we do here? We take the 4th root of 81. So what are 2 factors of 81? 9 and 9. And then so we have 3 times 3 times 3 times 3. How many numbers do we need to circle here? 4. So what goes on the outside? 3. Is anything left on the inside? Nope. The index number, so this number out here, so this fraction, the number on the bottom becomes our index. So the index is the number out here, and that number tells us how many we need to circle. And remember, if there's no number out there, it's implied that it's 2, so you just circle 2.
What if you have a number that's different than 1 in the numerator?
We're going to get to that.
What if something's like on the inside
Other than,
like you see how it's just all threes? Like what if there's just like one number that is
so if we just had like a times 5 on the inside too?
Yeah.
What do we do with the number that's not included in our circle? It stays on the inside, so it would be like 3 square root 5. Okay, part B. What do we do for this one? Where do we start? We take the square root of what? 121. So we're going to treat this as 2 problems. So let's do the first part first. So we're going to do the square root of 121. What are some factors of 121? 11 and 11. Do we have a pair? So we just circle our pair. So what's our answer going to be here? 11. Now for 256, what's our index going to be? The number on the outside. 4. We get it from this fraction here. So we have 4 on the outside. What are 2 factors of 256?
4.
4 and... You said 4. You gotta come up with another one. So how much?
Something with the 4.
64. Perfect. You can just divide 4 by 256 and do it that way when Rebecca comes back. So we have 4 times 64. We can break down 4 if we want, but let's just leave it for now and see what we come up with. What are 2 factors of 64?
4.
4 and?
Yeah.
Why not 8 and
8 and 8 works. What about 4 and 16? That also works. If we do 8 and 8, we'll get the same answer at the end. So, you're after Jaylene. So we have 4 times 4 times, what are 2 factors of 16? 4 and 4. How many numbers do we need to circle here? We need to circle 4. How many 4s do we have? 4. So what's our answer for this part going to be? 4. So when we have 8 to the 2 over 3, we keep our index the same as the cubed root of 8, and then we just square that at the end. We could also do it the other way, and we could square the 8 in the beginning, and then take the cubed root of that answer, and we'd get the same thing. So for this, on the order that we do it in, it kind of just depends on what our number is. Like, we know 8 squared is 64, but we don't really know what the cubed root of 64 is. We know what the cubed root of 8 is, which is 2, and then 2 squared is 4. So it's almost easier just to do it this way. So you do the square root first, or the cubed root, whatever the root is first, and then you do the number on top second. So let's do some examples. So simplify each expression. We can rewrite this as 16 to the 4th root, and then this answer cubed.
That's 4.
So 16 to the 4th root, what are 2 factors of 16?
4 and 4.
4 and 4. What we need 4 numbers to circle, so we need to break this down more. What are 2 factors of 4? 2 and 2, and 2 and 2. So we have 4 2's that we can circle. So what's our answer here? 2. But then we still need to cube that. So now we need to do 2 times 2 times 2. So 2 to the 3rd power is the same thing as saying 2 times 2 times 2, which is 8. So our final answer here would be 8. Okay, let's look at B. Now we have 1 to the 5th root, and then this cubed. What is 1 to the 5th root? 1. And then what is 1 cubed? 1. So what's our answer here going to be? 1. Okay, next one. What do we do first here? Put the 3 on the outside. So we have the cubed root of 27. And then what do we do with the 4? Perfect. So we have the cubed root of 27 to the 4th power. So 27 breaks down into 9 and 3. And 9 breaks down into 3 and 3. So how many numbers are we circling here? 3. So we have, what's our answer for the inside part? 3. And then we need to do 3 to the 4th power. So this is like saying 3 times 3 times 3 times 3. We can just group them together first. So what's 3 times 3? 9. We could do 9 times 3, which would be 27, and then 27 times 3 is 81. Or we could just do the other 3 times 3, which is 9, and then multiply the 9 times 9, and we know that is 81. Okay, we have quite a few examples left, but I'm going to skip to the last page. So now we have some with, okay, so let's do, from the last page, A.
The last one's first.
Okay, we'll do A and C, since the last one's the worst one, I guess. So here we're taking the square root of 16. So when we do the square root, it's like saying the square root of 16 times the square root of x to the 8. So we can break it down into two parts. What is the square root of 16? 4. So it breaks down to 4 and 4. We circle the two 4s, so we get 4. If we broke down 8 x to the 8th power, it would break down into 8 x's. So x times x times x times x times x times x, 1, 2, 3, 4, 5, 6, 2 more. So we're just going to circle pairs of 2's. So we have 1 pair, 2 pairs, 3 pairs, 4 pairs. So what do you think is going to come out? If we have 4 pairs,
4x.
x to the 4th. So 4 x's are going to come out, so we have x to the 4th that comes out here. So our final answer here would be 4x to the 4th. Yes?
Why don't we just make like one big pair? Like, are we allowed to do that?
Answer needs to be this. So whatever you can do to get to that answer. Another way of thinking of this, so we know that, I'm going to do it on the side over here. So we have x to the 8. We know the square root means that it's like the power is to the 1/2. So we have 8 to the 1/2 power. So it would be like saying 8 over 2. What does 8 over 2 simplify to? 4.
Oh, I see.
So it's the same thing there. So let's do C. So here we can split it up, or we could just keep it together. We'll split it up. So we can write 8 x's and then 12 y's, or we know that we have x to the 8, and that's to the 1/4 power, and then we have that times y to the 12 to the 1/4 power. So if we multiply these two together, we get x to the 8 over 4, which, what's 8 over 4 simplified to?
4.
What's 8 divided by 4? 2. And then we have y to the 12 over 4. What's 12 divided by 4? 3. So we have x squared times y cubed as our final answer. So this, one way you could do it would be to write out all the x's, x times x times x times x 8 times, and then just circle the groups of 4's and take out however many groups of 4's you have. Or you could just divide the number you have on the inside by the index on the outside. Okay, any questions from today?
No, this was kind of easy.
It is not too tricky.